Okay, guys, I'm going to put a couple of reactions up here on the board because I think we talked about this like once, and we never talked about it again, so you've probably forgotten it. But it's something that can come up with prediction questions. Okay? So. Okay, I want you to write those two down and see if you can figure them out. Okay, you may run into a problem if you don't remember the one time we actually talked about what goes on with this situation. Okay, and that's all right, we'll cover it. Okay, so first step is write out the reactants, right? So I'm going to write out that I have nickel, and it is reacting with calcium chloride. CaCl, that's a -1, that's a +2, so we have CaCl2. Okay, what kind of reaction is that? Okay, so who's the nickel going to replace? Calcium. Okay, so we're going to have nickel is going to end up with chlorine, okay, and calcium will end up by itself. All right, is calcium a special element? Okay, so then I check for my special elements. What do I need to do with the nickel chloride? How do I know what charge to use?
Use the most common charge.
Which one is that?
The first one.
The first one. Okay, so you guys remember like the one time we talked about that. Okay, I'm impressed. Okay, I'm not easily impressed. Okay, so what we do is we use the most common charge, which is the first one listed in the box. Okay, so for any of these multivalent metals, this only happens in like a single replacement reaction or a synthesis reaction. Okay, those are the only two situations where you could have a multivalent metal by itself with no indication of what its charge would be. All right, so what we do is we put, all right, 2+ is the most common because it's listed first. Now I can drop and swap. So this is the nickel with the 2+, chlorine is a 1-. Okay, so we'll have NiCl2, right? And now, oh, look at that, it's already balanced. Okay, everybody with me there? Same deal on the next one? Okay, so I have copper, okay, and it's reacting with iron 3 oxide, so Fe3+ with O2-, so Fe2O3, okay, also a single replacement reaction, okay, so who's copper going to replace?
Iron.
Iron, okay, so iron's going to be by itself, okay, and copper is going to end up with oxygen. Copper's most common charge is? 2, okay, so +2, -2, so that compound is good the way it's written, okay, and now I just need to balance the reaction. I would say since 3 is the biggest number, I should put a 3 there, a 3 there, and a 2 into 1, and I think we're good. Okay, that making sense? Mm-hmm. It's just one of those rare kind of exceptions that comes up, and we just have to be ready for it. Okay, whoever's phone that was, turn it off, please. Okay. All right, any questions with that? Okay, now I have picked a few that are a little trickier here that I would like. I think this one is also in the workbook, so if you have the workbook printed, these ones are in there, okay? But these ones they almost all have some little exception or thing you have to watch for, lots of special elements, okay, things like that. So I'm gonna leave those on the board and we'll do a few of those, okay, and then we'll see how we're doing from there, okay? Now, a few of these, what makes them difficult is also how I write the question. I make it sound like it's, well, a strange question or like a it's a story, and you've got to figure out what you're dealing with, okay? You will run into something like that. Okay, guys, let's have a look at the first one here. So we got lithium nitride. Is that ionic or molecular? Okay, so Li, okay, that's a +1. Nitride, okay, -3. So Li3N. Okay, and it's reacting with water. How should I write water in this one? I should probably write it as HOH, but if you wrote it as H2O, you'll just get a different answer, okay? And it won't be wrong, it'd just be different, okay? But in a double replacement reaction, okay, what we typically try to do is write it as HOH. Okay, so in this one here, what's acting as the metal here?
Hydrogen.
Hydrogen, all right, so double replacement reaction, I am going to swap the metals, okay, and so that is going to end up with H and N being together, okay, and Li and OH being together. Does it matter which one of those compounds I write first?
No.
It doesn't make any difference. Okay, -3 +1, so we got H3N there, okay, and then for this one here, we got Li, that's a +1, we got OH, that's a -1, so that compound is also fine the way that it is written. Now what do I do? Balance, okay. 3 is the biggest number and it's on 2 different things, so we'll just start with lithium. Put a 3 there, that gives me 3 OHs, putting a 3 there, okay, should make that all work out nicely. 1, 3, 1, 3. Okay. All right, how many people have done number 2? All right, so again, this question was kinder than I would be, because on a test, I would definitely not give you that juicy little tidbit, okay? I'd make you remember that sulfur is a special element. So we got zinc plus sulfur. All right, what kind of reaction is that?
Synthesis.
Synthesis, okay. So when those two go together, I'm gonna get this, okay? What kind of compound is that?
Ionic.
Okay, does it need to be dropped and swapped? Yes.
Already.
Is it already?
Yeah.
Yes. Okay, because this is a +2, okay, this is a -2, so they already work out, okay, we don't have to worry about any of that. Okay, biggest number is 8, okay, so put the 8 there, okay, and come back here and put an 8 and a 1, and we should be good with that one. Okay, now question number 3, how many people have done 3? Okay, so question number 3, sometimes when I write a question like this, okay, it's to throw you off, okay? And I don't mean like that in a mean way, it's to make sure that you're reading carefully, okay? A bunch of people will look at bauxite and then they'll go to the table and be looking for bauxite somewhere, okay? Bauxite is an ore, it's just a rock that contains aluminum, okay? So all you have to do is kind of go past that and go, oh, it contains aluminum oxide, and that's decomposed using electricity. So what this really looks like is aluminum oxide is going to do this. All right, so sometimes a reaction kind of gets hidden in a strangely worded way. All right, so it's going to break down into aluminum and oxygen. Either of those special?
Yeah.
Which one?
Oxygen.
Okay, here's something I see happen a lot, and I don't know why. For whatever reason, with aluminum, people do this. Okay, I don't know why, it's like the only one that it happens with, but are there any special metals?
No.
Yes.
Except for hydrogen.
Hydrogen. Okay, but, all right, it was a trick question, I'm sorry, that was me. Okay, there are no special, like metals, solid metals, okay? So aluminum is not special, but I see people do that for whatever reason, okay? Just know that that's not gonna have a 3 beside it. Okay, so now I've got my special elements, there's no other dropping and swapping to do, so, gotta balance. Which do I balance first? Okay, 3 and 2, what's the lowest common multiple? Okay, so I'm gonna put a 3 here, and a 2 there, and 4. Okay, you'd be surprised how often I see people put like a 2 over there. Okay, they forget. They just little details, especially if you're on a quiz or a test and you just get a little bit anxious and you just rush a little bit. Okay, those are the kinds of things that people slip up on. if they're just getting a little rushed or they're just a little bit anxious. Okay. All right, we're not going to do number 4. Why? Yeah, but it would be like the 11th time we've done it or something like that, because we've done it way too many times. Okay. I want you to try those 3, and then I'm going to have you do something else, because I want to practice something else as well here. All right, let's look at the first one here. So we got sodium chloride, ionic or molecular? Ionic. Okay, now if you're getting annoyed that I keep asking all those things, these are like the steps that you probably just go through without thinking in your mind, but I always vocalize them, okay, just so that we always get that review. Okay, so that one's okay the way it's written, okay, NaCl, okay, and it's reacting with lead 2 nitrate, which is also ionic, okay, and the Roman numeral tells me it's the 2+, and it is with nitrate, which is -1. Okay, so when I drop and swap this one, I'm going to need brackets. Going to need a 2 outside the brackets, and then that one will be good. Okay, what kind of reaction is this? Double replacement. Okay, in a double replacement reaction, what happens? Metals switch. Okay, so that means sodium is going to end up with nitrate. Lead is going to end up with chlorine. Right? Do both of those need to be dropped and swapped?
Yes.
Okay. So -1 + 2. How did I know the lead was a +2?
From before.
From before, right. If it's a 2 on the reactants, it's a 2 in the products. Okay. And then this would be a +1, that would be a -1, that would be okay. Got to balance. What should I balance first?
Nitrate.
Yeah, nitrate or chlorine, it really doesn't make any difference which one, they're both 2s. Okay, so we can do nitrate first. I'll need a 2 there, which will give me 2 sodiums, and then I think we're good after that. Okay, here's something that could happen on a unit exam, let's say. Maybe, definitely. Okay, so I give you a reaction just like that. I just tell you sodium chloride reacts with lead 2 nitrate, okay? And it's a multiple choice question. And I say, which, if any, of the products are soluble? Okay, how do I figure that out? Okay, go to my solubility chart. All right, now, I know sodium nitrate's soluble because nitrates are soluble, okay? But I got to check the lead. Oh, look at that. Okay, this would produce a what? It would produce a precipitate. That precipitate would be lead 2 chloride because according to my chart, it's not soluble. So this multiple choice question would probably go something like this, okay? A would be like sodium nitrate, okay? B would be lead 2 chloride, okay? C would be both, and D would be neither. Neither. I never spell that right. It's I before E except after C except in all these cases where it doesn't apply. Neither one looks right. English is a stupid language. Okay. Neither. I before E except after C except when it doesn't look right. This looks better.
Potato.
Isn't that weird? Spelled correctly. Remember the rule? I before E except after C. Isn't that weird? Sorry, tangent. Okay, so the multiple choice items would look like that. Now, I'm going to repeat how the question went because people will screw this up. Which, if any, of the products are soluble? What's the answer?
D.
A. Which, if any, of the products are soluble? All right? This is an example of, hey, I got to read questions carefully. Now, I'm not heartless, okay? So on a question like that, I would bold-face, italicize, and underline the word soluble, okay? So that it's going to attract your attention because naturally, our minds go to, I did all this work and I found out that that one's a precipitate, and I put that as the answer. While you did everything right and you know exactly what you're doing, the fatal flaw is you didn't read the question carefully enough, okay? And then get the answer wrong just because you didn't read it carefully. So, the moral of this long and pointless story is, okay, that you need to read questions carefully. And if I bold-face, italicize, and underline something on, let's say, a test or a quiz, it's probably important. Okay? Everybody with me there? All right. Okay, let's look at number 6 here. So we got aluminum react in a single replacement reaction with sulfuric acid. I would not be that kind. Okay, I would not tell you it's a single replacement reaction. Okay, what's aluminum going to swap out? Hydrogen. Yeah. Okay, so hydrogen is going to wind up by itself. Okay, and aluminum is going to wind up with sulfur. Okay, any special elements?
Hydrogen.
Yeah, I almost wrote the 2 just out of habit. Okay, that's a special element. Okay, is this ionic? Okay, so plus 3, minus 2, so Al2, S3. Okay, and then we got to balance that. 3 is the biggest number, so 3 there, 3 there, 2 there, I think. We'll make it work. All right. Okay, and then number 7, potassium hydroxide, so K with OH, okay, that's already swapped and dropped, -1 plus 1, right, with copper 2 nitrate. Okay, as a note before we finish this one off, for your lab reports, brackets are something that people miss in the analysis when they're writing out the reactions in formula form. It's very common for people to forget to put brackets around their polyatomic ions. If it doesn't have a bracket, and it should, are you going to get it right? Are you going to get the balancing right? Okay. It's kind of a big deal, so make sure you're keeping an eye on those brackets. Okay. All right, so what kind of reaction? Double replacement. Okay, so potassium and copper will switch places, so Cu with OH, okay, and K with NO3. All right, this was a +2 on that side, so it's a +2 over here. So again, in case where we need brackets, that one's okay, -1 and +1. Okay, so got a balance here, need a 2 there, and a 2 there, to fix everything. Okay? All right, just so you know, your unit exam, which, still a ways off, okay, is going to have some multiple choice. Okay? Right now, it's sitting at about 35, I think, somewhere 33. Okay, because I'm still playing with it. And it will also have, I think right now it's sitting at 8 written response questions. Now, the written response questions, there's a couple of questions in the written response. Right now, like I said, I'm still playing with it. Okay, that would require you to explain something, right? Really about the only thing that we've done in this entire unit that requires explanation would be the polar nature of water, okay, and solubility, right? So there's maybe a question on each one of those that would require you to think a little bit and write out an explanation of something. Okay, the rest is all the skill stuff we've been working on. Okay, I don't see myself changing this, but the first question, it's 1 and then it goes A through F, and it's just balancing. It's fill in the blank, balancing. You don't have to do anything but balance. Okay, so the first written response is just balance these reactions. Okay, and then there's some write the reactions out. So here I give you the whole reaction, you write it out, identify the type and balance, just like we've been doing. Okay, and then there's some predicting where you get it in words, you got to write it out, predict the products, balance.
So we don't have to describe all the models of the atoms like that?
That would be in the multiple choice.
Okay.
Yeah, but no, I'm not going to have a written response question that requires you to regurgitate everything about all the models of the atom. No. Okay. I'd say in the multiple choice, you'd probably need to know a couple of important people and be able to recognize a model if you saw a picture of it. Yeah. Okay. All right. So those are the kinds of things if you're already looking, ahead to what kind of stuff should I study. Okay. this test is heavily laden with skills and much less with memorization. So if you're saying to yourself, oh, just read over my notes 20 times. Let me save you 19 times reading over your notes, okay? You can read over your notes 1 time and practice all the skills the other 19 times, okay? That would be naming, writing reactions, balancing, predicting, using your solubility chart, skills, okay? It's all skills, so practice, practice, practice is the best way to study for chemistry and physics, okay? Biology, read your notes 20 times, okay? 'Cause, yeah, that's all about reading and remembering. All right. Okay, I don't want you to do all of these. There's just a couple here I want you to do. So this is actually a step backwards, right? These are, the reactions are completely done, okay? But just kind of looking at a few things here, I think we need to practice the writing part just a little bit more.
For question 6 on the last one, how do you know it's acids?
You know, that's why I put the H2S in there, because we haven't gone over the acid naming rules. In Chem 20, you do go over how to name acids. So if it's ionic compound with an element, it'll end in ic. So it'll be like hydrochloric, sulfuric, okay? Like those are like HCl, H2S. And then if it's, I'm forgetting, it's been so long since I've done it. Nitrous acid would be like hydrogen nitrate. I think that's how it goes. There's a different name, but we don't.
Thank you.
Yeah. Okay, so a few here, guys, that I think are going to be valuable for us to practice our writing out of the reactions in word form. Okay, 3. 5, 7, and 8. 3, 5, 7, and 8. Okay. Definitely want you guys to try those. Okay, so why did I want us to do number 3? What do we not do a lot of? Molecular compounds. Okay, and so when I throw them in there, sometimes people forget, okay, just because we don't do a lot of them, right? So carbon and chlorine, both non-metals, so this is going to be carbon tetrachloride. Okay, and that is going to decompose into carbon plus chlorine. Yeah. Okay, so that's what it would look like in word form. Obviously, we already said it's a decomposition reaction. Okay, so I need to balance this thing. 4 is the biggest number, so what do I need to put here? 2. Right, okay. Is everything else okay? Yeah. All right, for number 5, why did I pick this one?
We must include Roman numerals.
Right, okay. On that last quiz, probably the most common mistake on, what was that question? I can't remember what question it was forgetting the Roman numerals on both the reactants and product side of that one reaction. I think it was copper was involved. Okay, so that is why we are reviewing this one here. So this is going to be iron oxide, and then to figure out the Roman numeral, okay, oxygen is always a -2. 3 times -2 is -6. So I got to get 6 positives from the 2 irons. 6 divided by 2 is 3. So this is iron 3 oxide plus silver. Okay, gives us silver oxide and iron. Does the iron need a Roman numeral when it's by itself? Okay. Yep. All right, so just little things like that, guys. It's those little nitpicky details that I just find it's always good to review. Okay, number 7. What kind of reaction is that? Okay, it's a double replacement. I don't know why, that's not supposed to be it's not supposed to be a negative there. That should just be COI2. You can't have -2 iodine atoms. Okay, last time I checked. So, we got cobalt, and that would be 2 selenide. Okay, plus manganese, and that would be the manganese with the 4 plus charge, iodide. Okay, and that is going to give us cobalt 2 iodide, okay, plus manganese 4 selenide. Now, tip, in a double replacement reaction, okay, when it's being written out in words like this one, a very common mistake that I see is people putting the Roman numerals in the reactants and not in the products. Does it need to be on both sides? If it's in a double replacement reaction? Definitely. Okay? Just make sure you're double checking that. Okay? If you got a Roman numeral somewhere, make sure that it followed it along where appropriate. Obviously, in the one we did up above, not appropriate for it to follow it along. Okay? But in a double replacement reaction, it is. It's in a compound. The Roman numerals need to be on both sides. Okay? All right, and then we got polyatomic ions. Okay, for number 8 here, so we've got ammonium chloride, okay, and it is reacting with sulfur, okay, and that is going to make ammonium sulfide. Okay, and chlorine. Oh man, I haven't been balancing any of these. We gotta go back and balance some of these. I forgot. Sorry guys. And then if we're looking at what kind of reaction that is, it would be a single replacement. Okay, let's go back and do the balancing. Okay, what should I balance first in this reaction? Sulfur, big number, right? So put an 8 there. Okay, that's gonna give me 16 ammoniums. So I'm gonna need a 16 there. That's gonna give me 16 chlorines. So I'm going to need an 8 there. So some big numbers in that one. All right, for number 7 here, 4 is our biggest number for the iodine. So I'm going to put a 2 there to balance the iodine, a 2 here to balance my cobalts, and then everything else works out as a 1. Okay, and then for number 5, probably the oxygen should be done first, so I need a 3 there for the oxygens. That gives me 6 silver, and then a 2 here in front of the iron should make everything work for that one. And then for this one here, oh, we already did that one. So I actually did remember to do one of them. Okay, I'm going to give you guys about a 5-minute break here, and then we'll look at some of the other ones, and then we'll call it. I think you guys are getting this pretty well. Okay, so these ones are just straight prediction again. Okay, write them out in formula form, predict the product's balance. Okay, and we'll see how we do with those. Okay, so for number 5, is that exactly the situation we started class off with this morning? Right, where we have a reaction where I've got a multivalent metal, but I don't know what its charge is to begin with, but I've got to put it in a compound later. Okay, so it's exactly the same situation. Okay, I've got copper reacting with fluorine gas, so I know it's weird. I'm going to start with number 5. Okay, it's reacting with fluorine gas, F2. Okay, special element. Okay, and that's going to make CuF2 because 2 is the most common charge for copper. Okay, all right, and then it's already balanced the way that it's written. Okay. For number 1, dicarbon hexahydride, C2H6, okay, burns in oxygen gas, so O2, all right, gives us CO2 and water because it's a combustion reaction. Do I need both balancing rules for this one?
Yes.
Yes. Okay, so put a 2 here, that's 4 carbons, put a 4 there, 12 hydrogens, a 6 there. 4 times 2 is 8, plus 6 more is 14. 7 times 2 is 14. Okay, and then sodium nitrate reacts with magnesium. Okay. Sodium nitrate, that's NaNO3, that's reacting with magnesium. What kind of reaction? Single replacement. Okay, so magnesium is going to wind up with nitrate, and sodium will wind up by itself. Okay, and then magnesium nitride breaks down, Mg3N2, right, is going to break down into 3Mg plus N2. Sorry, I've been forgetting to balance these. 2 and 2. Okay, and then this one is balanced the way I have it written. Okay, and then the last one, sodium permanganate, so that's NaMnO4. Okay, reacts with iron 2 sulfide, FeS. Okay, that's going to give us Na2S plus FeMnO4 2, and a 2 there I think fixes everything balancing wise. Okay, you feeling good about this? All right, here's what we're going to do. I'm going to give you the assignment that I was going to give you yesterday because it just occurred to me we have a shortened period tomorrow because we have maths tomorrow. We have altered bell schedule, so periods are going to be just ever so slightly shorter. So why not give you the extra time today? We don't need the extra time for practice. Okay, so I'm going to give you the extra time right now.